Narrowing down candidate exoplanets using exoplanet detection methods. The United Nations Population Reference Bureau predicts that by 2150, Earth will be considered inhabitable because of overpopulation. Overpopulation places stress on Earth's resources, both renewable and non-renewable. Disease rates will increase, and environmental pollution will skyrocket. These effects will soon become irreversible. The purpose of the study is to provide more information and analysis of exoplanet candidates and, if possible, determine their full habitability. The habitable zone, or HZ, is a theoretical area surrounding a star where any nearby planet could support life or have liquid water on the surface. A stable HZ has two factors. First, no large mass body should be close to the HZ because it disrupts the formation of Earth-like bodies. Second, the HZ range should be consistent. All stars get brighter as they age, and a given HZ near that star should move outwards. But if this happens rapidly, this gives a planet a weaker chance to develop life. Ergo, that star must survive for a long period of time. Because of those two requirements, most of the stars being searched are F, G, K, or M stars. These letters classify stars based on stellar classification. F, G, K, and M stars are the cooler stars, temperature-wise. The blue band in this diagram represents the location of the HZ. Notice, as expected, that for low-mass, cool stars, the region is closer to the star, and for higher-mass, hotter stars, the region is more distant from the star. In this particular illustration, the Earth appears to be precisely in the middle of the HZ for the Sun. Also known as radial velocity measurement, Doppler spectroscopy is a common method to detect exoplanets. First off, the Doppler effect is a change in frequency of an electromagnetic wavelength from an observer moving relative to its source. It's used to calculate the speed at which stars and galaxies are approaching, blue shifts, or moving away, red shift, from a source. Doppler spectroscopy involves the observation of Doppler shifts in the spectrum of a star around which a planet orbits. Periodic variations in a star's spectrum will occur where the wavelengths of characteristic spectral lines increase and decrease. This may be indicative of the radial velocity of the star being altered by the presence of a planet orbiting the star, causing Doppler shifts in the starlight. If an exoplanet is detected nearby, its mass can be determined from the changes in the star's radial velocity. The transit method is based on the observation of a star's small drop in brightness when the orbit of the star's planet passes in front of the star. The amount of light lost depends on the size of the star and planet, and the duration of the transit depends on the planet's distance from the star. Size and mass can be determined using spectroscopic observations. Ian Sample, 2005, noted that astronomer Abel Mendez ranked exoplanets from best to worst candidates for life. Gliese 581z and HT 85512b were ranked highest. The rankings were determined by three different scales, one based on the planet location in the HZ, the second is called the Earth Similarity Index, which ranks planets according to how closely their mass, radius, temperature, and atmosphere matches Earth's. The third scale ranks according to whether the estimated surface temperatures are suitable for life-like plants to grow. Michael Mayers, 2011, utilized Doppler spectroscopy to locate exoplanets. His conclusion resulted in the discovery of many low-mass planets with orbital periods less than 100 days, but unfortunately, these qualifications don't fit the appropriate criteria for habitable planets. Nevertheless, his experiment, according to this graph, supported that Doppler spectroscopy progressed the precision of exoplanet detection, as the amount of discovered exoplanets significantly increased since 1990. Jason Barnes, 2007, calculated how transit window size varies with period and geometric transit probability in, believe it or not, 245 exoplanets. It was concluded that with extremely carefully timed measurements, the transit window size increased, which brought window monitoring to ground-based program reach. An overview of his results is displayed in these four graphs. The top left represents dependence of transit window, the top right being the transit midpoint uncertainty, the bottom left of the predicted transit duration, and the bottom right is the relation between transit window and probability. All four graphs appear to have almost the same correlation, with the exception of the obvious positive-negative sign. As for the experiment procedure, archived exoplanets will be the target of the study, the most likely candidates being Gliese 581d and HT 85512b because those were ranked with the highest habitability. Their characteristics will be observed with the Pholx and Gemini telescopes, which provide access to telescopes in Hawaii, Australia, and Chile. The Gemini Observatory especially provides access to both the northern and southern skies. Additionally, online astronomy simulators, such as the Circumstellar Habitable Zone software, provide the same service. Utilizing the telescopes and simulators, characteristics such as orbitals, mass, luminosity, and energy can be determined. The transit method will definitely be a large component, which will be performed with the simulator. The MEADE LXD75 telescope with DSS-7 spectrograph attachment will be used for Doppler spectroscopy of the stars, which will allow information about nearby exoplanets to be deduced, as previously mentioned. Additionally, metallicity can be determined from this process. All data will be quantitative and will undergo a Pearson's correlation statistical analysis test with Earth's current information. If things work out in favor, the exoplanet data should result in a correlation value of R greater than 0.9 with Earth's data, indicating very strong similarities. This will be the budget. The Manhasset Science Labs already own the telescope and spectrograph. The online simulators are free to use, and the availability to the Pholx and Gemini telescopes are accessible through usernames and passwords. Consequently, the point of this experiment is to narrow down the possible exoplanets for future human habitation. Gliese 581Z and HD 85512b will be observed and analyzed through the Pholx and Gemini telescopes, which will take note of their planetary characteristics. Additionally, the transit method will particularly be applied using the online astronomy simulator, the Circumstellar Habitable Zone software. Doppler spectroscopy will be applied utilizing the telescope-spectrograph combination, which will determine radial velocity and metallicity. In the end, all the quantitative data from every determined characteristic from the two exoplanets will undergo a correlation statistical analysis with Earth's information. A predicted R value of greater than 0.9 will be established. Thank you for your attention.